Intermediate Algebra for Statistics, Parameter, Value, Mixture, and Break-Even Problems Involving Systems. Part 5. Lesson objective: use a system of two linear equations or a linear function to solve parameter, value, mixture problems, and break-even problems. This will be our last example for systems of linear equations. It's a break-even problem. Example 10. A company has incremental production costs of $8 per unit it produces, and the company's fixed costs are $950 monthly. A. What price would be charged to break even at a production quantity of 250 units per month? B. Using the price in Part A, how many units must be sold to make a profit of $2,500 per month? C. Using the price in Part A, if 1,000 units are sold per month, how much profit would be made? So we'll begin with A. We are given that the production quantity is 250 units. So this example is a little bit different than we did in the previous video. In this example, the variable is the retail price that will be charged. So we want to compute what price needs to be charged for retail to break even if we make 250 units per month. We're going to let C be equal to the retail price, or the revenue cost, it can be called, for the unit. So this means how much does the product sell for. So the total revenues will be the number of items, which we know is 250, times what we're going to sell it for, which is C. The total cost will be our fixed cost, which is 950, plus the variable cost, which it costs from the problem $8 per unit, and we have 250 units. So the total cost turns out to be $2,950. So if you recall, to find the break-even point, we take the total revenues, which is 250C, and we set that equal to the total cost, which is 2,950. So we have our equation, 250C equals 2950, divided by 250, and we see that C is 11.8. So the price, the retail price that is, for an item should be $11.80 for the business to break even if 250 units are sold per month. Part B, using the price in Part A, how many units would be sold to make a profit of $2,500 per month? Our variable is how many units. So we're going to use the cost in Part A, and we're going to find out how many units must be sold to make a profit of $2,500. So our variable is going to be the number of units, which we'll label the variable N. Next, we need to recall the formula for profit. Profit equals revenue minus total cost. Profit we know is $2,500. The revenue will be the retail cost times the number of items, which is N, minus the total cost. So profit's $2,500. Using the price in Part A, $11.80, times N, minus the total cost, which is our fixed cost, $950, plus our variable cost, which is $8 per item times the number of items. The next step is we want to distribute the negative. The equation now becomes 2,500 equals 11.8 times N minus 950 minus 8N. Now we combine like terms. We get 2,500 equals 3.8 times N minus 950. Add 950 to both sides, and now divide by 3.8, and round it off, we get N to be about 907.89, which we're going to round that to 908 units. The business will have to sell about 908 units per month to make a profit of $2,500 per month. C. We know that 1,000 units are sold. We're using the price, retail price from part A. How much profit would be made? So again, we use our profit formula. This is our variable. We're using the retail price from part A. We know that N is 1,000. Our fixed costs are fixed. And then our variable cost would be the cost per unit times the number of units, which is 1,000. Next, we do the parentheses. So 8 times 1,000 plus 950 is 8,950. And we subtract that from our revenue, which is $11.80 times 1,000, which is 11,800. And we have a profit of 2,850. So in the terms of this problem, if 1,000 units are sold, the profit will be 2,850. Let's do a quick review. The methods to solve a system. If you recall, we started off with the graphing method, where we use either a graphing calculator or we can use graph paper, and we graph the lines that relate to the equations, and we look for the point of intersection. If you recall, we can have one solution where the two lines intersect at one point, no solutions where we have parallel lines, and we can have an infinite amount of solutions if the lines coincide, if the two equations are the same. Next, we did the substitution method. Now this is the first algebraic method that will give us exact answers. And the last one was the elimination method, and this is best to use when the x's line up, the y's line up, the equal signs line up, and the constants line up. Solving a system of linear equations allows us to do many real-life applications. So in the previous videos we have done perimeter problems, total value problems, mixture problems, and last break-even problems. Thanks for watching.